This video is designed to help you determine the difference between an arithmetic and a geometric sequence, and to look a little bit at exploring the terms of those sequences and seeing if we can come up with an expression for finding the fifth term or the nth term. So to start with, an arithmetic sequence means that you add the same thing consistently to the previous term to get the next term. So for example, the arithmetic sequence 5, 7, 9, 11, and so forth says that you start with a number, in this case 5, and we'll call that the first term, a sub 1. And what you do to get a sub 2 is you add 2. So to get a sub 3, once again, you add 2. So this is a sub 3. To get a sub 4, you add 2 again, and so on. So an arithmetic sequence, so arithmetic means you're doing arithmetic, kind of at the basic level, I guess. So it's the most simple of these sequences. Means that the first term is a sub 1, and the second term, that in this case is 5, a sub 2 is 5 plus 2, or 7. A sub 3 is a sub 2, the second term, plus 2, so that's 7 plus 2 equals 9, and so on. So that means you should be able to come up with, say, the 6th term or the 8th term or the 10th term by recognizing the pattern. So that the pattern is that you're going to come up with the nth term, we'll call it, as 5 plus 2 times however many times you've added it at that point. So in the first term, a sub 1, you've added 2 0 times. So that means you've added it 1 less than n. In other words, 1 minus 1 is 0, and you've added 0 2's. On the second term, you have added 1 2, which is again 1 less than the number of that term. So for example, what that means is you're going to do 2 times n minus 1. So what that means, and we can verify this, is whatever term you want, if you want the, say, 100th term, so that means the 100th term is going to be 5 plus 2 times 100 minus 1. In other words, you're going to add 90. You're going to have added 99 2's. In other words, 1 less than the number that names the term. Okay, so you could calculate this out fairly simply as 5 plus 200 minus 2, which is 198. And so that's going to be 203. So the 100th term in this sequence is going to be 203. So a geometric sequence is a different kind of beast. What that means, so a geometric sequence, again I'll write geometric sequence, means that you are multiplying the previous term by some factor. So what that means is you could see something like 5, 10, 20, 40, etc. So if we look at the first term, again that's 5 in this case, and what we did was we multiplied by 2 to get the second term, and then we multiplied by 2 to get the third term, and then we multiplied by 2 to get the fourth term, and so on. Okay? So what we're getting here is some starting number, which we're going to call a sub 1. And then what we're doing is we're multiplying by some factor, in this case 2, since we're doubling each time. And what we need to do is figure out how many times we're multiplying by 2. So the first term, let me change this around slightly. better way to write this is that the first term, a sub 1, is 5 times 2 to the 0th. Now I write 2 to the 0th just to remind us 2 to the 0 of course is 1, so this is just 5. The second term then is the first term, a sub 1 times 2, which is 5 times 2, in this case, to the first, or 10. Right? And the third term, then, is going to be the second term, a sub 2 times 2, which is 5 times 2 squared, which in this case is 20, and so on. So what this allows us to do is recognize the nth term again. And so the nth term is going to look something like the following. So the a sub nth term is going to be, it's going to be the first initial term times, in this case, a whole bunch of 2's. How many of them? Well, you'll notice in the first term that we multiplied by 0 2's. In the second term, we multiplied by 1 2. In the third term, we multiplied by 2 2's. And so what it's going to be is 2 to the n minus 1. So we could calculate the 100th term, which is a very, very large number. But let's just say, let's do the 10th term. So a, or the 11th term, that's an easy one for me to do. The 11th term is 5 times 2 to the 10th. I happen to know that number because it's a nice sort of base 2 number to keep in mind. So it's 5 times 1024, which is going to give us 5,120, if I'm doing my math right. 5,120, excuse me. Okay, so there's two examples of an arithmetic and a geometric sequence and identifying the terms in them. So now let's take a quick look at a couple of sequences and see if you can identify whether they are arithmetic or geometric. So here are 5 examples of sequences, and we're going to try to identify what each sequence is, whether it's arithmetic or geometric. Also, of course, keep in mind that not every sequence is either arithmetic or geometric. It might be neither of those. In a special case, it could be both, but we're just going to concentrate on identifying whether it's arithmetic or geometric. And not trying to identify if I've tried to trick you and it's neither. So the first sequence, 6, 8, 10, 12, you can see what the pattern is. Each time we are adding 2, adding 2, adding 2, adding 2, and so forth. You can see that the next number in the sequence would likely be 14. This is arithmetic. The second sequence, in this case, what we've done is we've taken the first term and we've multiplied by 2. You could argue you're adding 1, but then did we add 1 in the next term? And the answer is no. To get the third term, no. So we can look at it and say, oh, we came along and we multiplied by 2, we multiplied by 2, we multiplied by 2. Therefore, if we multiplied by 2 again, the next term in the sequence would be 16. So this is geometric. I'll just write geom. The third sequence, and of course you can try these on your own. The third sequence, if you look at it carefully and look for a pattern, what you'll identify is that in each case we are adding 4 to get the next term. It's tempting to say you've doubled it, and then you've tripled the first one, and then you'd quadrupled the first one, but we're always looking back at what we did on just the previous term. So we take the first term, add 4 to get the second term. We take the second term in the sequence, add 4 to get the third term. Take the third term, add 4 to get the fourth term, and by this rule, the fifth term would be 20, Once again, this is arithmetic. And now we'll look at sequence number 4. This one's a little bit harder. You could look at it and you say, well, if you triple 8, you get 24. But if you triple 24, you don't get 40. So let's look and see if it's arithmetic. What did we add to 8 to get 24? Well, we added 16. If we add 16 to 24, we're going to get 40. If we add 16 to 40, we're going to get 56. And therefore, if we add 16 to that term, to the fourth term, we should get the fifth term, which is, of course, going to be 72, if I'm correct. And, of course, that makes this an arithmetic sequence as well. And finally, let's look at the last one, a little bit trickier. What's happening? Well, we could argue that we're subtracting 16 to go from 4 down to negative 12. But then if we were going to subtract 16 again, we would go to negative 28, and that certainly didn't happen. So how did we get from 4 to negative 12 if we did a multiplier? Well, in this case, it means that we multiplied by negative 3. So this one's a little tricky. If we take negative 12 and multiply by negative 3, once again, we're going to get positive 36 because a negative times a negative is a positive. And if we do that one more time, we should get negative 108. And let's see if I can do this in my head. It's going to be times negative 3, so that's going to be a positive number, and it's going to be positive 324. And this, of course, then is a geometric sequence. Okay, hope that's helped.